Every year, the ground beneath our feet trembles more than 500,000 times. Most of these earthquakes are too small to feel, but occasionally the planet reminds us of its power, with devastating force. Buildings crumble, cities fall, lives are changed forever. But here is a question few people ask. Are earthquakes simply natural disasters, or do they play a deeper role? A role in making life on Earth possible? To answer that, we first need to understand what earthquakes actually are. Beneath your feet, the Earth is not solid, it is broken, fractured into massive pieces called tectonic plates. These plates are enormous slabs of rock, some as large as entire continents, and they float on a layer of partially molten rock deep below the surface. They are never still. They creep forward at the speed your fingernails grow, a few centimeters per year. But when plates meet, they don't slide smoothly. They catch. They lock. They grind against each other, building up immense pressure over decades, sometimes centuries. And then, the strain becomes too much. The rock fractures, the energy releases in a violent instant. That release, that sudden violent snap, is an earthquake. Throughout history, earthquakes have reshaped civilizations. In 1960, the most powerful earthquake ever recorded, a magnitude 9.5, struck Chile, killing thousands and sending tsunamis across the entire Pacific Ocean. In 2004, a massive undersea quake off the coast of Sumatra triggered a tsunami that claimed over 230,000 lives across 14 countries. In 2010, Haiti was devastated by a magnitude 7.0 earthquake that killed more than 200,000 people and displaced millions. The destruction is real, the human cost is immeasurable, and yet there is another side to this story, a side that is rarely told. To understand it, we need to look at why earthquakes happen in the first place. The Earth's interior is hot, incredibly hot. At its core, temperatures exceed 5,000 degrees Celsius, comparable to the surface of the Sun. This heat drives a slow, relentless churning of rock deep within the planet. That churning is what moves the tectonic plates. Where plates pull apart, new crust is born. Where they collide, old crust is pushed down and recycled. Where they grind sideways past each other, energy builds and releases as earthquakes. 3 types of boundaries: convergent, divergent, and transform. And each one is a different expression of the same planetary engine. Now consider what that engine has built. Every mountain range on Earth, the Himalayas, the Andes, the Rockies, the Alps, exists because tectonic plates collided and pushed rock skyward. The ground you walk on was shaped by millions of years of seismic activity. Without earthquakes, there would be no mountains. Without mountains, there would be no rain shadows, no river systems, no diverse climates across the globe. But the benefits go even deeper. Tectonic activity is Earth's recycling system. When one plate slides beneath another, it carries water and minerals deep into the mantle. This process releases gases and nutrients back to the surface through volcanic activity, enriching the soil, feeding ecosystems, and maintaining the delicate chemical balance of our atmosphere. Plate tectonics also regulates Earth's climate. Over geological timescales, the movement of tectonic plates drives the carbon cycle. Carbon dioxide is pulled from the atmosphere and locked into rock. Then, through volcanic eruptions and tectonic activity, it is slowly released back. This cycle has kept Earth's temperature stable enough for life to exist for billions of years. Without tectonic activity, Earth would likely resemble Mars or Venus. A dead planet with a stagnant surface, no recycling of nutrients, and no mechanism to regulate its climate over long periods. In fact, many scientists now believe that plate tectonics may be one of the essential conditions for complex life on any planet. Think about that for a moment. The same force that levels cities also builds mountains. The same process that causes destruction also recycles nutrients, regulates the climate, and has kept Earth habitable for 4 billion years. Earthquakes are not just disasters, they are the heartbeat of a living planet, a sign that Earth is still geologically active, still creating, still renewing itself. When we look at Earth from space, we see a world of breathtaking beauty, blue oceans, green continents, white clouds. But what we cannot see is the engine beneath the surface, the slow, patient movement of tectonic plates that has shaped every feature of this world. So the question returns, are earthquakes simply random violence, the unfortunate byproduct of a chaotic universe? Or is there something more at work here? A system so elegant that the very forces capable of destruction are also the ones that make life possible. The same processes that can bring devastation also help make Earth the only known cradle of life in the cosmos. Earthquakes remind us that our world is not static. It is alive, constantly changing, constantly reshaping itself, constantly writing the next chapter in a story that began 4.5 billion years ago. The question remains, is this merely a coincidence? Or was it designed?